This is the answer to your warm-up. We're talking about matter today. And in case you knew this, you probably didn't. Chemistry is generally considered the study of matter. That's what we call chemistry. It's and if you think about that, though, that encompasses everything. Okay? Literally, it encompasses everything that you can imagine in this world, except for some really far reaches of outer space. Because everything has matter, or is matter, we'll say. So, first thing, matter. Anything that has blank and takes up space includes all materials found in nature. Does anybody have any idea what that blank might be?
Mass.
Okay. It is mass. So write that down. I'm going to guarantee, I'll just guarantee right now, that's a test question. I'm going to tell you that. I'm going to literally ask you, what is matter? You got to know it's anything that has mass and takes up space. Now, what does that mean? That could literally refer to anything. I mean, air particles. You can't see them right now, but they take up space. I mean, they're filling the room, and whether you know it or not, they do have a mass. It's not a lot, but they do have a mass. Very teeny tiny amount. I mean, you know, everything else, most things that you can see, it has mass, takes up space. So everything, basically, is matter. Unless you're in a pure vacuum where there's literally nothing. And even, believe it or not, up in space, right around the Earth, there still is stuff out there. There's still atoms, molecules floating around up there. Not a lot of oxygen, and it's generally a vacuum. But the further out you go, like if you go outside our galaxy, you go outside the cluster of galaxies that we're in, blah, 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 then you might get somewhere where there's literally nothing. That's maybe, I guess, where we're not studying. But everywhere else we're studying. So anything that has mass takes up space. Those are the two keys. You can't have one without the other and have it be matter. Next. What are the three states that we talk about for matter?
Solid, liquid, gas.
Good, you know this. Solid, liquid, gas. Generally, I would have you run around the room to demonstrate these things, but we'll stop and not bother today. Even though it is kind of fun if you do. Now, what we're going to really do now is talk about some different types of matter. And I'm trying to keep this short so we can get to the burning of things. But, you know, we talk about some different things, and the first one we're going to talk about is substance. Now, let me just tell you this right here. Fill this in. Has a definite chemical composition. So a substance is basically, it's sort of just like one type of matter. It could mean anything, but it's one type of matter consisting of one type of, you know, configuration. Whether it be an element or a compound or whatever, it's all the same. Now, the first thing that we're going to do that's pretty important is this. Okay? Elements. You've heard me talk about them. Okay? You've seen this. I mean, we've referred to them as though you know what's going on with them. Maybe you do, maybe you don't. But an element is anything you're going to see on this table. Okay? Anything on this table is an element. Now, the one thing that's important here, the element is the smallest unit of matter that you can't break down anymore. Okay? So what that means, let's say I've got this thing here. We'll say that is one big thing of copper, 200 grams of copper, with a little bit of steel on the top, if you can see it there. But it's 200 grams of copper. It's all copper. Now, if I were to break that down into individual molecules, or not molecules, but atoms, okay, and we had to have a bunch of atoms of copper. If I then took out the protons and the neutrons and the electrons, can you tell protons, neutrons, electrons apart? Like if I took a couple from here, and then I said, hey, let's take a couple from boron, put some protons right next to each other, would you know which protons were from boron, which protons were from copper? No, they're positive one charge, they have a massive one, you can't tell the difference. Okay, you cannot tell the difference. So, the key with the element, the big key, is that it is substances that cannot be further decomposed by ordinary chemical means. They're made up of only one type of atom. Now, what it really means is, and another thing I want you to add here, they are the smallest. I'm going to try to write this nice and neatly. You know what? I'm going to do this instead. Watch this. Smallest unit of matter that retains unique properties. So I would like you to add that in, actually, and write that in, please.
But that's visible for me?
I know it's kind of small. I'll zoom in here. So, please add that in right there. Smallest unit of matter that retains its unique properties. That's the key here. Because once you break it down smaller, everything's the same. But when you have elements, they're different. You can tell them apart. An atom of gold is a lot different than an atom of silver. One's worth a heck of a lot more. Okay? Yeah, this is going to... No, this is like in addition. It's more for element. I'm just kind of... I like to emphasize things. Now, next. Okay, next is compounds. This one's not that, I guess, difficult or challenging. It's just, you've heard this term, and I'm going to go quickly through this. It's two or more different atoms that are chemically bonded together in a fixed ratio. What that means, fixed ratio, you know this. You're well aware of this, actually. H2O, that's the compound. What's the ratio always in water?
2 hydrogens and 1 oxygen.
H2O. 2 hydrogens, 1 oxygen every time, no matter what. If it's H2O, OH, or H2O2, those are all different. Okay, you got to have 2 H's, 1 O to make it water. If you have H2O2, that's hydrogen peroxide, which is something totally different. You know, have you seen that stuff? It comes in the dark bottle, the opaque bottle, so light doesn't get in. Because actually, that bottle is black, so it does not let light in. Because if you let light in and hit hydrogen peroxide, it reacts and it neutralizes it, and then it just turns into water. So that's why they don't let light in, by the way, if you ever cared. All right, mixture. Next type. Contains 2 or more kinds of matter, each retaining its own chemical properties. Now, what does this mean? Well, let's give you an example of this. Why not? The key thing with a mixture. Alright, if you have a mixture, let's say this. I've got some sand. There's sand in here. I've got salt. And I'm going to fill this beaker with water.
Let me turn on the light, Mr. Ed.
No, it's all. I'm going to put it up here. So, there's some water in there. Now, I'm going to add a little bit of sand. Well, actually, salt first. There we go. Woo.
You can't see anything.
You can see that.
I'm gonna cry because you can't see salt in water.
Now, you can see a little bit of it there.
That's
Now,
not honey, you moron.
hey. Anyway, there's salt in there now. Now, is the salt still salt? There's still salt. Did it react with anything? Did it change anything? It might dissolve, but that's okay. If salt dissolves, that's not the end of the world. That's fine. It's still salt, though. Water's still water. So, does it retain its chemical properties?
Yeah.
It's a mixture of salt and water. Now, I'm going to add some sand here, too. Yes, salt plus sand equals explosion. No. So now there's some sand in there. This is actually really heavy. So, you'll notice... So anyway, you notice, we've got sand, we've got salt. It's retaining its individual properties. Now, this is what we would call a mixture. Okay? Now, it contains 2 or more kinds of matter, and each one retains its own characteristics. It has not changed anything. Okay, we'll get back to this in a second. Next, there are 2 types of mixtures, okay? These right here. 2 types. You might want to make a note. Now, we've got homogeneous mixtures and heterogeneous mixtures. Now, homogeneous mixtures are matter that has identical properties throughout. So, it's anything that has the same unique properties look throughout. An example. Well, let me give you an example. How about let's look back at our nasty slime. It looks like slime. We've got sand in the bottom here. We've got salt in the bottom. Is this perfectly uniform and identical throughout the entire beaker?
Yes.
Why? Someone tell me why they think that is. Raise your hand. I'll call on you. It'll be a big fancy what?
I think it is because it didn't change any of the states. They just stayed on the bottom.
The states are the same, but is it the same everywhere?
No.
No, it's not. That's the key. Someone over here, a lot of you seem to be opinionated. Why is it the same? Or why is it not the same? Or what do you think? No idea? No. And does anybody have an opinion where they want to raise their hand?
It's no, because it's all on the bottom and then you go to my top where it says it.
Oh, they actually gave a decent answer there. All right. The question is this uniform everywhere? I mean, in the full volume of the water, is it completely taken up by an equivalent distribution of sand, salt? No, it is. This is not homogeneous throughout. Because if I take, I don't want to stick the pen in there, but if I take some sand or some water, you know, my finger's all wet now. All right. From the top, it is not the same as the bottom. There's sand on the bottom. There's not sand on the top. Sand does not float, does it? No, it doesn't. So, that is not a homogeneous mixture. That is what we would call a heterogeneous mixture. Okay, and this is different properties. So it's matter that has different properties throughout. Homogeneous would be the same. Can anybody think of an example of a homogeneous mixture? What?
If you put food coloring in the water.
Yeah, that'll be the same throughout.
Does anyone want to donate to Adopt a Family?
We're gonna pause for a moment while people donate to families. I'm saying
It's gonna give you all the
fancy like
change.
that. All right, we'll have it on video. You donating to families in need. Pretty handy. By all means, interrupt my wife. Anybody else? Sorry, my class is cheap.
Thank you.
What are
Good
you
for
doing?
What are you doing?
I don't have cash. I never bring cash to school. No, I know. I'm always worried about bringing cash to school and having someone steal it. I don't trust people. I'm cold-hearted. All right, focus. Shh. Shh. We're almost done. We had one example of a homogeneous mixture, which would be when you dissolve, if I had any food coloring, I'd do this, but when you dissolve food coloring in water, can you tell that stuff apart? Does it all look the same throughout? That's homogeneous mixture. Heterogeneous is, again, something like sand and salt or something like Italian salad dressing. Anything that says you got to shake well before you use it, that's a heterogeneous mixture. Because stuff settles to the bottom, you know, it's not evenly distributed throughout all the time. Okay? Now, almost done. We're almost done. Solution. Okay, these are homogeneous mixtures. And these are just kind of like vocabulary words, definitions you're going to have to know, containing a solute and a solvent. Now, this is actually probably the most important thing for you and that you might care about here. Solute and solvent when you talk about stuff being dissolved, because you deal with this on a daily basis in your life, probably, maybe. You might mix things together. You drink all kinds of solutions every day. You drink pop, you drink energy drinks of different types all the time. Those are solutions, horrible solutions filled with awful things. I was at this conference. When I was at this conference last week, one of those days I was gone, there was this like 60-year-old woman who drank like 4 Red Bulls. It scared me. Like, I mean, like she just sitting there, said, "Oh, I gotta stay awake. I gotta drink another one." I'm just like, "You're like 60. This is not safe for you to do this." No, I mean, does she?
Yeah, because she goes.
No, but I just mean like it was crazy. I mean we're just sitting there and she's just pounding back. Actually, it was 2 Red Bulls and 2 Rock Stars. Is that an energy drink?
Oh, Rockstar?
Yeah.
I love Rockstar.
I couldn't believe it. Anyway. Anyway, here's the deal. Solvent. We're going to do the bottom one first here. The solvent. Okay? It's basically the larger quantity in a solution. So right now.
You wrote it in the wrong.
No, I said I'm doing the bottom one first. So if you look here, we have our fancy, awful, nasty-looking solution. You've got water, salt, and sand. Now the sand doesn't dissolve, right? Sand does not dissolve in water, but salt does. So we have a solution of salt water here. What is there obviously more of? Salt or water?
Water.
Water by a mile, right? There's a lot more water than salt. So water in this case is the solvent. The solvent is what holds stuff. It's what stuff dissolves into. It's generally water. It's almost always water, just so you know. The solute, okay? The solute is the smaller quantity. It's what is dissolved in water. It's what gets dissolved. So it's what breaks down. Okay? Yeah, it's like you put sugar in coffee. You put some of that powdered cream into coffee. Yeah, you put sugar and Kool-Aid mixture into water. Yeah, any of that. Those are solutes. The water being the solvent. Okay? So, those are actually kind of important things for you. So when you go to the coffee shop, aka, actually I don't know, where do you guys get coffee?
Starbucks, man.
Okay. By the way, if you know that if you didn't get coffee on I don't know if some of you drink coffee on a regular basis, you would save so much money if you didn't do that. By the way, just think about it. I mean, how much does a cup of coffee cost at Starbucks? Like $3? $4?
Smallest
I
three.
didn't even drink coffee.
My God.
My house is free.
What about like Tim Hortons?
Three something.
What?
Think about, if you spend $3 a day every day, that's what is that? That's $15
What
a
is
week.
Speedway? Hey, Speedway's $1.
Okay, you spend $1. That's $5. That's like
You get like 10
it's a lot. I mean, that's a lot of money. Think about if it's $3. That's like $1,000 you're spending every year on coffee. It's a good racket they got. Anyway, I should probably get rid of this now, huh? Anyway, we're almost done. I don't drink coffee. That's actually one of the reasons, because I'm too cheap. But anyway,
I just seen Bitch on the video. Hey, how it is?
stop.
Hi, Mom.
Actually, that's nothing. I got a kid in here in fifth hour. Whenever I do this, it's Yusuf's son. Anytime I do this, he takes his ID out and tries to stick it in front of the camera. Why? I don't know. Because it's like he wants me to see later, oh, hey, Yusuf was not paying attention. Anyway, whatever. So this chart, by the way, this is super important. This might be the most important thing on this whole deal. Okay? Yes. Now, this chart tells you how we break down and classify matter. We're almost done, then I'm going to light stuff on fire, I promise. Now, this chart tells you how we break down matter. Notice you start with matter at the top. Okay? You start with matter at the top. That's where everything begins. Then, there are two things we can go from there. You can go to substances or you can go to mixtures. There's two ways to view this. Substances are made up of elements and compounds. This side is truly what we're going to focus on the most in this class. Okay? Because we're really looking at elements, we're looking at compounds, mixtures of things. Not mixtures, pardon me, compounds. Next trimester, Chemistry B, we'll focus a lot more on mixtures. We'll be looking at solutions a lot. Colloids and suspensions, I'll kind of explain what all that is later. We'll get there. Now, this is the part on the bottom here that we kind of care about. Properties of matter. Why? Because that allows us to light things on fire. So, properties of matter. Now, there's two types. There's physical and chemical properties. Okay? So, let me just tell you what to write down here. This is identity. And then this is behavior. But don't just let all that disappear. Keep it there for a minute. Don't put it away yet. Okay? Physical properties, chemical properties. Okay? Physical properties can be determined directly without changing the identity or composition of material. Examples here. A physical property would be something like odor, color, taste, solubility, whether it dissolves or not, a hardness, density, melting point, boiling point, like texture, feel.